This photograph shows a typical rainy street. On Earth, we rely on a predictable, gentle weather system, driven entirely by liquid water and solar heat. But elsewhere in the universe, precipitation means mountain-sized diamonds falling from the sky, and breezes are replaced by winds roaring faster than the speed of sound. These golden hexagonal mirrors belong to the James Webb Space Telescope. It recently pointed its instruments toward a massive exoplanet orbiting a pulsar. A pulsar is a rapidly spinning dead neutron star that constantly fires out lethal beams of gamma radiation. Out in the deep universe, standard meteorological rules simply break down. Weather in these distant systems completely ignores water, relying instead on crushing pressure and bizarre alien chemicals. Earth's fragile ecosystem is highly unusual. To understand the true limits of physics and meteorology, scientists have to look out into the raging storms covering the rest of the cosmos. Take Saturn's largest moon, Titan, where precipitation runs on chemical substitution. This diagram maps a local weather cycle. On Titan, liquid methane acts like Earth's water. It evaporates from the surface, forms convection cells, giant looping currents of moving air, and falls back as rain, filling vast alien lakes. Deep inside the ice giant Uranus, temperatures climb past 12,000 degrees Fahrenheit. The pressure there is so extreme that it literally snaps those methane molecules apart. Which brings us back to that newly observed exoplanet. The pulsar it orbits is extremely hostile. These rapidly spinning stars emit so much radiation that they usually strip nearby planets apart and eat the material alive. This visualization shows the strange chemistry of the planet's atmosphere. It contains massive amounts of free-floating carbon. Normally, carbon links with oxygen or nitrogen, but here it refuses to bond. Instead, immense pressure forces it to crystallize into mountain-sized diamond hailstones sinking toward the core. On a cosmic scale, precipitation is dictated entirely by a planet's internal thermodynamic pressure. Water is completely removed from the equation. Atmospheric movement is also driven by these extreme conditions, starting with the runaway climate on Venus. Venus experiences superrotation, where its atmosphere races 60 times faster than the solid surface below. Winds hitting 250 miles per hour drive a massive double-eyed vortex over the South Pole. On Earth, the sun is the primary engine for weather. But for gas giants, extreme internal planetary heat replaces the sun entirely to drive the atmosphere. This simulation shows an atmospheric tantrum deep within Saturn. Lightning bolts tearing through these thick yellow clouds carry 10,000 times more power than strikes on Earth. This false color image captures Saturn's North Pole. The wind streams naturally lock into a perfectly geometric six-sided pattern. That hexagon has been spinning continuously for at least 40 years. Further out, Neptune receives only a tiny fraction of the sunlight we get on Earth, yet it generates the most extreme wind speeds in the entire solar system. This close-up view reveals Neptune's great dark spot, an evolving storm system roughly the size of Earth itself. Surrounding it are supersonic jet streams that exceed 1,300 miles per hour. The universe's most violent wind streams do not require solar energy. They are fueled by massive internal planetary engines hidden deep beneath the clouds. Planets also project invisible weather systems, their magnetic fields. Look at the axis in this diagram. The Webb telescope data confirms that Uranus's magnetic shield sits completely crooked, tilted about 60 degrees off balance from its rotation. Because of this misaligned shield, Uranus creates wandering auroras. Instead of staying neatly at the poles, these glowing particle storms stretch across huge regions of the planet's equator. A planet's physical orientation radically alters how charged particles move through its atmosphere, completely reshaping its primary defense against space radiation. Bringing this back to the diamond-raining pulsar planet, the sheer amount of carbon in its atmosphere means it defies all known planetary formation models. This conceptual illustration visualizes one hypothesis. The planet is the ultra-dense surviving core of a destroyed star, stripped of its outer layers by the pulsar. The other possibility is that it's a pre-existing planet, mutated over millions of years by extreme radiation. Earth's quiet weather is a fragile anomaly. By tracking diamond storms and supersonic winds, scientists are actively mapping the true boundaries of physics across the universe.